Hello everyone. Today I will be talking to you about the Curiosity rover. For those of you who have not heard about this robot before, it is the rover that was recently sent to Mars. I'm going to talk about three important topics that have to do with this robot. The first will be what makes this robot unique from others that have been previously sent to Mars. The second is what is Curiosity's goal on Mars, and the third, the funding of this robot and future missions by NASA. So, the Curiosity rover is very different from previous probes sent to Mars for many reasons. One is that this rover cost over $2 billion to make. It's a lot. But this is by far the least interesting fact that I'm going to share with you today. So, this robot is capable of doing a great number of things. It's basically a moving laboratory on 6 wheels, completely automated, that's on Mars. What it can do is it can look around with that one big eye, with its super high definition camera, until it finds something that's interesting to look at. It then drives up to this object and takes a sample from the surface. It then takes the sample inside the robot and vaporizes it with a super high, really strong laser. The laser vaporizes the chemicals, and then it's able to see what the compounds make up the thing it just scraped up off the ground. So if this looks interesting to NASA scientists, then it will ask the robot to dig deeper into the rock and extract more samples, because the samples in the rock are older than the ones on the top, so they have more history. So this is pretty cool, saying that this thing is all the way on Mars. But, okay, switch to the next slide. There's a lot more stuff it can do as well, as you can see. So, now, another interesting point is that the power source that this robot uses is very different from the ones that the previous rovers on Mars used. The previous rovers used solar panels to power themselves. And that's great and all, but after a couple of years, the solar panels started to break down and get covered in Martian dust, which you can't simply wipe away like we do here on Earth. Curiosity uses a different source of power. It basically has a radioisotope power system, big words, by NASA, which is a block of plutonium, which is about like 4 Rubik's Cubes like that, and it can power Curiosity for a minimum of 14 years, which is a lot longer than any of the other rovers. So now that we know a bit more about this robot, let's go on to my second main point, why it's there. So after Curiosity's 350 million mile journey to Mars, when it finally landed, its mission is to investigate, one of its missions is to investigate the surface and the underground parts of Mars. It is searching for several things, one being flowing water. You can switch the slide. Yeah, that's by the way the plutonium. It's red. And so, this is an image from Mars. So raise your hands if you think that looks like there used to be water there streaming down. Yeah. Alright, next one. How about these ones? Does that look like there was ever water there? Alright, those of you who put your arms up, scientists agree with you. Good job. But they can only hypothesize this far because we're not completely sure yet. That's one of the missions Curiosity is there to fulfill. And we're not sure until Curiosity can vaporize those specimens I was talking to you about. So some of you might start to think, why should we spend $2 billion on a robot that wants to find out if there was ever water on Mars? No, I agree. Until I read this article by NASA. So I'll give you 3 missions why Curiosity is there. One is to investigate the chemical building blocks of life that are on Mars, such as carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfate. So by looking for these building blocks, it can find out if Mars was ever a hospitable place for life. The second is to interpret the processes that have formed and modified rocks and soils. From the previous slide that I showed you, you could see that some of the rocks look like pebbles, like the ones we see here, as if they were molded by the current in rocks. flow there many thousands of millions of years ago. And the third is to assess the long time scale, 4 billion year time scale, of Martian atmospheric evolution processes. Mars, way back in the day, had an atmosphere, but now it does not because it is too small a planet. The atmosphere has gone out into space. So that's how NASA puts it. And now let's go on to my third main point. Number 3. NASA's got severe budget cuts this year because of the government, going from $18.4 billion a year in 2011 to $17.43 billion in 2013. So this might seem like only a small portion of NASA's total money, but if it keeps going down like this in the future, NASA's going to have issues if it wants to send more probes to Mars or anywhere else. And NASA's hoping that it will continue to be funded, and if not by the government, then by people like you. So by making small contributions, we as a people can help NASA continue on. It doesn't necessarily have to be NASA either. There are many space agencies around the world who are hoping to be funded as well. And so I've talked a whole bunch about supporting them with money, but it doesn't have to be money either. You can just be interested in the field. You can research and learn, and someday you could be on the frontier of space innovation. And you could even just build a robot like I did. Look, it's beautiful. And so you can build a robot. It's all part of the research. It's all that one day you can make a contribution to NASA or any other space agency around the world. So although mine can only avoid walls, which I'm pretty proud of, and while NASA's can vaporize samples from deep inside rock on Mars, it's all a step forward to mankind. Thank you.